Okay, folks, here we go. If we were meeting in person, and it would be the second evening of class, the most important thing out of that second evening, now it's all important, chemistry, hello, it's all important. But the most important thing that you would get on our list of things for that evening, here's our list, and we've gone through all this stuff, atomic theory, proportions, people, names, formulas, blah, 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 right down here. Naming compounds, or writing formulas for them. So naming them and writing formulas are actually the opposite. We're going to go through naming formulas, the most important thing of this evening. Okay, well, if we were meeting this evening. So the most important thing is learning how to name compounds. It's a language. You got to learn the language of chemistry. Now, you can learn you don't have to learn a foreign language. You can actually have a German to English dictionary and go ahead and speak with somebody who's German by looking up each word individually. As you saying your sentence. It might take you, for just say one sentence, it might take you 20 minutes, but you could do it. We do the same thing here in chemistry. I suppose you could look up how to pronounce every single compound that you're going to see while you're using it. Okay, good luck with that. That's going to take a little while. So you got to learn some of the basics. You have to be able to at least have a basic knowledge of how to speak chemistry language, yes. So I know fluently 6 different languages. And 7, if you include chemistry. That would be my 7th language I am fluent in, all right? What languages? Oh, okay, yeah. What language am I fluent in? Well, English, obviously. All right, British, Scottish, Canadian, Australian. Okay, there's 6 of them. And I'm working on New Zealandish. So I'll be fluent in that one by next year. So you can see I am fluent in multi-languages. Okay, now, language of chemistry. How do we speak it? Back here, I've already constructed a flow chart. If I didn't do this before, I'd be doing I'd spend half the time doing this video writing. So it is written down. There's a flow chart. So I hope that you will be able to, by the time we go through so many namings of compounds, that you'll be able to have this flow chart in your head. Your brain will work like this flow chart. You won't even know. It'll be magic. You'll be looking at a compound, going, naming it, and you will be doing this without even thinking about it. So here we go. I'm trying to stay out of the way. Usually I like to stay over here, but then I'm in the way of this part of the flow chart. Okay, I hope you can read that. I try to be kind of neat. Oh, I think you can. Yeah, I think you can. All right, so here we go. First of all, you want to get the chemical nomenclature sheet that I had loaded into you in the announcements in Canvas. You want to get this because I'm going to go through a lot of these right here. So this is chemical nomenclature, practice problems level 1. There is also practice problems level 2. Okay, a little bit more difficult in naming. We'll start with level 1, and here we go. Well, actually, the very first one right there. Okay, what is it? NaCl. Well, most of you know that that's sodium chloride. NaCl is common table salt. You know that, but let's see why it's called sodium chloride. Let's use our flow chart and follow and see if the flow chart leads us to the promised land, people. First question you're going to ask yourself when you see a compound is it binary? Bi meaning 2. That means 2 different elements. Does it have 2 different kinds of elements in it? If it has 2 different kinds of elements, it's binary. If it doesn't have 2 different kinds of elements, it's not binary. So let's see what the flow chart tells us. It has some sodium and it has some chlorine, NaCl. So that's sodium and chlorine. 2, that's binary. So sodium chloride is binary. Is it binary? Answer, yes. Follow the chart. Follow the yellow brick road, people. Wizard of Oz once again. So here we go. Yes, it's binary. Boom. Now ask yourself another question. Is there a metal? Is there a metal in the compound sodium chloride? Now, we've gone through the basics of the periodic table. And doggone it, you should know that when you have your periodic table, okay, step-like line over here on the right, anything to the left, those are metals. If you're to the left of that step-like line, you're a metal. I mean, you could be a metalloid if you're right on the borderline there. But sodium is way over here on the left. It's the most metallic thing that's almost on the whole entire periodic table. The more left you are, the more liberal you are. No, don't talk politics. The more left you are, the more metallic you are. Okay? And the more right you are, the more conservative. No, I said don't talk politics. The more non-metallic you are. So left side sodium, that is a metal of metals. Okay, that is a super metal. So yeah, you got a metal in there. And you also have it connected to chlorine, which is on the right side of that step-like line. So chlorine is a non-metal. You have a metal and a non-metal here. So is there a metal in that compound? Yes. Okay, follow the yellow brick road, yes. Next question. Is the metal, sodium, in the middle of the periodic table? Middle of the periodic table? What do you mean the middle of the periodic table? I'm talking about this group here we call the transitional elements. Remember, we went over this. The transitional elements, which are from scandium across to zinc and down. And actually this group here that gets these two periods, these rare earth elements that get pulled out, those are also considered transitional metals. So is sodium in the center group? Center groups? The answer is no. It's, again, way over to the left. So it's not. It's not in the middle of the periodic table. So is it in the middle of the periodic table? The answer is no. Then name the metal, sodium, add IDE to the non-metal. And let me write that down because I don't want you to be all confuzzled. Add IDE to what? Sodium? Sodiumide? That's not right. If it doesn't sound right, it's wrong. That's the way it's kind of going to work. It doesn't sound right, it's wrong. Add IDE to the non-metal. Now, the non-metal in this case is chlorine. So you don't say chlorinide. You know that's wrong. It doesn't sound right. You know it's wrong. You just take out the INE and add IDE. Sodium chloride. Name the metal. Sodium chloride comes from chlorine, so chloride. All right, piece of cake. All right, so following the chart, it worked like a charm. All right, let's try another one. Let's try number 8. CO2. CO2, you know what this is. CO2, you better know what it is. You've been paying half attention to anything in the news for the last 20 years. CO2, carbon dioxide. We know it's carbon dioxide, but why is it called carbon dioxide? Why is it named that way? With the sodium chloride, I mean, when it comes to carbon dioxide, you said di, you said a prefix in front of that oxygen. Why'd you do that? Why didn't you say sodium monochloride? You didn't say a prefix in front of the chlorine, but you're saying one in front of the oxygen. Why are you using a prefix in one and not in the other? Okay, exactly. We need to find out why that is. Carbon dioxide, CO2. Let's go ahead and do our flow chart. Is carbon dioxide binary? Carbon, oxygen. Yes. Now, sometimes students go, no, it's not binary. That has 3 things in it. You have a carbon and 2 oxygens. No, that's not what I'm talking about for binary. Binary means you have 2 different elements. Now, you can have more than one of an element, but do you have 2 different elements, carbon, oxygen? Yes, so it's binary. So carbon and oxygen makes it binary. Yes. Is there a metal? Aha, here it is. Is there a metal in carbon dioxide? You take your periodic table, you find carbon, you find oxygen, and they're both on the right side of that step-like divider line. Those are 2 nonmetals. So is there a metal? The answer is no. Nine. No. Oh, I forgot German. That's another one I'm fluent in. Yeah, that makes it like 8 languages. So no, you are not. There's not a metal here. So you use prefixes and then add an ID. Use prefixes. What do you mean? If you have 2 nonmetals making a compound, you're going to use what's called the prefix naming method. Now, some of the prefixes we need to know. I'm going to fit them in here. I know I can see some room here. I'll fit them in over here. Okay, here we go. The number 1 is represented by the prefix mon. Yo, mon. So, I'm from Jamaica. Mon. So, mon. And I'm going to put an O up there. I'm going to put that O in parentheses. And there's a reason for that. Because sometimes you say mono and sometimes you say mon. The prefix 2 is di, hence the carbon dioxide. Prefix for 3 is tri. You know most of these. You do. The prefix for 4 is not quad. I mean, that doesn't mean 4, but that's not the prefix we use. We use tetra. Tetra. Now, I want to put that A in parentheses for the tetra, and I'll explain that in a minute. 5, 5-sided building in Washington. Pent. Call it penta. 6, hex. And hexa, I'll put an A in parentheses. 7 is sept. Sept, S-E-P-T. I know some of you are thinking, oh, like the month, September. It means 7. September is the 7th month of the year. Just like in, wait a minute. September is not the 7th month of the year, it's the 9th one. Oh, I'm confuzzled now. What about 8? Oct. Yeah, see, you know the 8th month of the year is October. Wait a minute, no it's not, it's 10th month of the year. What's going on? 9 is N-O-N, non. And then 10 is how many years in a decade? 10, D-E-C. And we all know that the 10th month of the year is December. Boy, that kind of barely fits on my screen there, doesn't it? Yeah, we squeezed it in though. We're all good. 10th month of the year is December. No, it's not. Okay, yeah, the Julius and Augustus Caesar, July and August, screwed everything up, okay? Just had to have one named after those guys. That's how important they were. All right, screwed everything up and it pushed everything forward 2 months. So they used to be that way, but the calendar is screwed up because of those people. All right, now, moving on. Okay, so this is going to be use prefixes, add IDE. So we had CO2, carbon. Now, some of you might be saying, why isn't it monocarbon? If there's one carbon, why don't I use the prefix mon? Come on, mon. Why don't you use the prefix mon? Why isn't it monocarbon? That doesn't sound right, right? You know that's not monocarbon. Di to dioxide. You know it's not. Because you don't use the prefix mon for the first element, ever. Now, if it's a compound like this one, and you know this one as well, CO, nasty, dangerous stuff. I mean, this stuff is bad. We give it up. Well, that whole carbon footprint thing. This is bad. This is like bad. It's poison, man. It's carbon monoxide. So these are two nonmetals. So is it binary? Yes. Is there a metal? No. Use prefixes. Okay, this would not be monocarbon. It's carbon. Don't use mon on the first one. Mon, because I have one oxygen. So you do use the mon prefix on the second element. So monoxide. Now it's not monooxide. That's why I put that parentheses around that O. You don't always use it. You don't use the double vowel sound. Don't use double vowel sound. So if it's not going to be carbon monooxide. It just doesn't sound good. It doesn't flow. So if there's a prefix MON is going to be used, and whatever is following it, like monooxide, you don't use the double vowel sound. So monoxide, drop the O. But if it's chlorine, you'd use monochloride. Okay, monochloride, because chlorine uses the C, and that's not a vowel, so you would use the vowel on the O. And the same holds true with these A's. Sometimes you say tetroxide, not tetraoxide. Tetroxide, you drop the A if there's a double vowel sound. Okay, now if it's chlorine, okay, that doesn't start with a vowel, it'll be tetrachloride. You would keep that A in there. All right, let's keep going. Let's do some more examples. Practice. We're talking about practice. Not the game I love, not the game I die for. Talking about practice. Allen Iverson, according to ESPN, best rant ever, 2005. Allen Iverson, look it up. Awesome. Okay, here we go. Let's do another one. Let's see. No, I don't want to do that one yet. Let's do, okay, we'll do this. Number four. CaSO4. Ca, I'll write it up here. CaSO4. Name it. First thing, is it binary? No. What? How is it not binary? Calcium, there's one element. Sulfur, there's two elements. Oxygen, there's three elements. That's not binary. It's trinary. So is it binary? The answer is no. Ooh, we're going to the right side of the chart this time. Nice. Okay. Is the metal, there will be a metal with it. You will have something which is, if it's not binary, you're going to have a metal. In this class anyways. We're not talking organic chemistry here. This is not organic chemistry. So you're going to have a metal. Is the metal in the middle of the periodic table? Now, again, that means, is the metal attached to this, which is going to be the calcium, the one on the left of your compound, your metal, potentially your metal. It doesn't have to be a metal, like the last one, carbon, doesn't have to be a metal. That's a metal, and we know it because we look right here, calcium, right there on our periodic table. There's calcium. Is that in the middle? Is that a transition element? The answer is no. It's one of the alkaline earth metals. So it's not a transition, not in the middle of the periodic table. So I answered the question no. Then go ahead, name the metal. calcium, and name the polyatomic ion. Remember, I put those polyatomic ions up here, and I said you need to know these. You just got to know them. And there aren't that many you really have to know. It's only like 10 of them. There's a lot of polyatomic ions, but there's just a group that you got to know. And one of them is SO4, sulfate. Okay, that is sulfate, SO4. You need to identify it as sulfate. That's why you got to know what it is. If you see SO4, you go, oh, I know that. That's sulfate. Easy. This is going to be calcium sulfate. Name the metal calcium, name the polyatomic ion sulfate. Nailed it. Done. All right. Let's try another one. Oh, this one's kind of interesting. Let's take a look at number 15. NaH4NO3. And I said Na. NH4NO3. Is that binary? Not even close. I mean, you got nitrogen, you got hydrogen, you got oxygen. No, not binary. So no. Is the metal in the middle of the periodic table? Now, if you go, oh wait, the thing on the left is the metal. So where's the metal here? You see, that's why you need to know your polyatomic ions. I told you got to know them. And if you know the 10 I told you to know, then you would know NH4 is ammonium. If you don't know NH4 is ammonium, you're not going to be able to name this thing. You're going to screw it all up. I know my polyatomic ion basic ones, and therefore NH4 I know is ammonium. So it's not binary. So it definitely has at least one polyatomic ion in it. In this case, it has two. That's why I like this one. It's unique. It has two polyatomic ions. It has ammonium, and it has nitrate, NO3, nitrate. Remember? Nitrate. Nitrate is cheaper than the day rate. The nitrate. It's cheaper than the day rate. Nitrate. Okay. So ammonium nitrate. If I know my polyatomic ions, chemistry piece of cake. All right, let's try another one here. I want to keep this video to 20 minutes, and I'm running up on time here. Let's see. Let's go to SO3, number 14, SO3. Now, most of you go, oh, I do know my polyatomic ions. You tell me to know them, and so I know them. And SO3 is sulfite. Sulfite, I know that. No, it's not. What? What do you mean it's not sulfite? You told us no, SO3 is sulfite. No, SO3, 2 negative. Ion, negative ion is that would be the polyatomic ion sulfite, but it doesn't have that negative 2. So this is a compound. This is a compound that has sulfur and oxygen. Is it binary? Yes. Is there a metal? No. Sulfur and oxygen are to the right of the step-like line. Use prefixes, add IDE. Sulfur, trioxide. Sulfur, trioxide. All right. All right, keep going, keep going, keep going. Oh, here we are. Let's see, I'm still on the side 1 here. You have HNO3. HNO3, it's one of those acids I told you to know. Okay, that would be nitric acid. If you just call it, if you identify it as nitric acid, I say, got to know these acids. It's nitric acid. You could also identify this, if you could also actually name this as hydrogen nitrate. You could actually do that, hydrogen nitrate, and I'd be okay with that. Hydrogen nitrate, you said nitric acid or hydrogen nitrate, I'd be okay with that. Okay, let's flip over to side 2. This is where it gets some fun. You might have noticed that we have done a compound here. We've done a couple compounds here. We did a compound here. No, we haven't done any yeses. If the metal's in the middle of the periodic table, here and here, what would we do? That's where the real fun begins. Okay, let's take a look at the back side here. Level 2 problems. Let's do the number 3. All right, you've got iron, FeCl3. Okay, name it. Is it binary? Iron, chlorine. Yes. Is there a metal? Yeah, you know iron's a metal. Come on, you know that. Iron's a metal. So yes. Is the metal iron in the middle of the periodic table? Well, let's find out. Iron, iron, iron. Whoa, that's about as middle as you can get. I mean, that's like boom, right there in the middle. That is in the middle of the periodic table. So the answer is yes. Okay, staying out of the way here. It says determine the metal's charge, use Roman numerals. What the heck does that mean? Determine the metal's charge and use Roman numerals. All right. So I have to determine the metal's charge it's using. Okay, the reason you have to do this, if you look at your periodic table, these transitional elements can use multiple charges. Sodium, potassium, rubidium always use a charge of +1 every time. Calcium, magnesium, did I say magnesium? I don't remember. Magnesium, calcium, strontium always use a +2. But if I'm iron, I can use a +2 or +3. I did give you a copy of this. And above it is +2, +3. That means it can use either a +2 or +3. What charge is it using? What charge? All right, so what I'm going to do, since we've hit the 20-minute mark, I'm going to stop this video and keep you on the edge of your seats. I know you are sitting there going, I'm so excited. I'm so excited. I want to find out why. I got to find out. No, don't stop. No, don't do it. No.